Hello. Today, I would like to begin our pitching with today's biggest global challenge, which is burning fossil fuel. And the solution to this is renewable energy, but it needs to be easy to integrate, economically feasible, and scalable, which is why I will be talking about torrefaction. These are the contents of my presentation. So, torrefaction is the process of converting low-grade biomass into high-grade biofuel with the goal to directly replace coal, which is a fossil fuel. The company we are looking at today is Blackwood Technology, which has utilized FlashTor to produce torrefied black pellets. The company is based in the Netherlands, but it has a plant location in Thailand, which is why I think it is very relevant to us. Now, the process for torrefaction starts with drying the biomass from 50% moisture content all the way down to less than 15% moisture content. The biomass is then heated in the FlashTor system, which produces two things. The tor gas, which are volatiles with low calorific value, which is then burnt in the combustor to provide heat energy for pre-drying and torrefaction, which is a great example of heat integration. The second product is then cooled down and then compacted or pelletized. This is the final product, the torrefied biomass. This is the production capacity and implementation of the system. It was first implemented in the Netherlands as part of a demo plant. It was then tested in several different coal-fired power plants to which the tests were successful, which is why they moved to implement it in Thailand. When they implemented in Thailand, they partnered with TTCL Public Company Limited, though the specific clients of the product was not mentioned. The capacity was, however, mentioned to be 75,000 tons of black pellets per year. These are some of the other R&D programs that Blackwood Technology has participated in, and this is just to show how extensive this is, even though it's a relatively new technology. Some of the pros compared to coal include the lower carbon footprint. Because the feedstock is renewable, the net CO2 emissions are much lower. Now, the infrastructure compatibility is very important and arguably one of the best advantages of this technology. Because we already have a lot of coal power plants, we can easily integrate black pellets into them because we just replace the black pellets into the system, which makes it very, very enticing for consumers. Now, generally, the lower ash content also makes the combustion cleaner than coal, which is why torrefied black pellets are preferred. Now, the other pros about black pellets as compared to the traditional wood pellet energy technology, includes the higher energy density, which means that it costs a lot less to transport and store per unit volume. It is also more water resistant, more durable, and has better grindability. Some of the cons include the high costs and the production challenges. It takes a lot of capital investments for the facilities. The boiler adaptations are also needed, and there are sustainability concerns because it relies heavily on biomass feedstock. Now, the future plans, as stated by Blackwood Technology, include introducing super black pellets, which is supposed to be a higher grade version of black pellets already produced by Blackwood Technology. It should have a higher fixed carbon content and lower volatiles. And personally, I would have these further recommendations here on the screen. The overall goal should be to improve calorific value so that it provides sufficient energy and can effectively replace coal. We should also reduce plant and process inefficiency to reduce the net carbon footprint, which is why I suggest more research, more testing, more experimenting, continuing to improve sustainability through heat integration, life cycle assessment, and waste reduction, as well as combining torrefaction with other downstream processes in order to produce higher grade fuel. Thank you very much. This is the references I use, and that is the end of my pitching today.